Okay everyone, welcome back to my YouTube channel. In this video we're gonna be playing with a Redis queuing package created in Golang. This one really caught my attention, so I really wanted to play around with it. I found it really cool, so hope you enjoy too and stick around. Okay, so the Redis package that I'm talking about is called is by Adjust over here. It's called RMQ, and it's a fully Golang spec package. The thing is that Redis doesn't provide like a queuing system. It provides a pub subsystem where if you are subscribed to the queue and there's a message pushed onto it, then you get that message, and all the listeners get that a message, but there's no queue service where one service takes that task off the queue, processes it, and the other services don't. So there's nothing really built in for that. So this package just works on top of Redis to try to improve that. So I'm gonna be using this package over here and a CLI package over here just to help streamline some things, because I want to have one terminal that's used for consuming and one terminal used for producing. So let's without further ado, let's get started, I guess. Open up our our VS Code over here. I already have a folder created over here. So what you want to do for Golang, you want to create a go mod init, and you want to essentially name this as the same URL as your GitHub repo where you're gonna put it. So I'll just say Floyd Jones 1 Redis Q. Cool. So go mod init that. And then another thing is that we need Redis. So we also are going to use Docker for this. So let's just create a Docker file. So Docker compose YAML over here. And let's focus on the Docker compose file real quick, because this won't take long. First, we'll specify version 3, and then we will start our services over here. And this one will be named Redis, and it has an image name of by Bitnami Redis. I'm not gonna map any volumes. I'm just gonna let the volumes kill themselves. One thing I'm gonna do is put an environment variable over here called allow empty password, and that was equal to yes, just so I don't have to input a username and password. And finally, ports over here. Oops, over here, and this is 6379 colon 6379 over here. So cool. So now we can get a Redis instance up, which is great. Another thing we want to do is create our main.go file over here. So let's do a couple of things. Package main, all housekeeping stuff, function main, and we just want to initialize this. So we're going to use the CLI package just to make things easier to sort of spin up like a terminal for consumers and a terminal specifically for producers. So let's just get this URL in over here. This is called package. Put that in over here. I'll also need the OS package over here. So how do we want to do this? We want to create a app variable, and it will be a CLI.app over here. This isn't a package. Oh, it's called import, my bad. Import over here. And now the CLI stuff, undeclared name CLI, it's getting it from here. So what we can do is just copy this over here. I just prefer to do go mod tidy, but also you can just copy this and say go get that, and that should get us the URL thing. Okay, and now we can create our different sub commands, because that's what we essentially want to do. I'll just call this RMQ over here. And usage for this is runs a Redis queue. And then over here, there's something called commands, which is an array of pointers, cli.command over here. Cool. So now in here, we want to have an array of different commands. So it's going to be the same thing. This one I'm going to say is the producer. Producer over here, usage creates Redis queue producer. And then finally, the last one is our, oh, I forgot a comma. The last one is our action. And this one, if we, I thought autocomplete would help us, but it's not. Autocomplete's not playing well with me today. So this one's just going to be, it's going to pass in a context, and it'll be cli.context, and it'll return an error over here. Finally, let's just return nil, just so it doesn't complain. Also, this over here, there's something funky, but we'll figure that out soon. We don't need this. We want version 2 of this. Oh, okay, we might have to, yeah. So let's just do go get that. Cool. So that should have worked. And now finally at the very bottom, we just want to say app.run, and we want to pass in the os.args over here, and it's just going to help os.args over here, which is just going to help process everything. So let's just do a couple of things. Let's just say fmt.println, I am the producer, and finally I'll just copy paste this just for time's sake. And then producer, I'm just going to change this to consumer creates Redis queue consumer. And then finally, I'll just say consumer over here. Cool. So now if we did things correctly over here, we can just say go run main.go, and then we can say producer, and we should get an output saying I am the producer. And then finally, if we do the same thing, but we say consumer, we should be seeing that as well. Well, that's cool. So we know that thing's working now. Let's just spin up our Redis containers. So if we do docker compose up-d, because we want it running in the background outside of the terminal. We don't want it to stay in this terminal. So there's started, created, so that should be good. So now let's create our connection to Redis. So how this happens is, let's first install the Redis queuing package. So if we do go get, and we paste that github.com/adjust/rqm/v5, that should help us get that. Let me save this. Oops. Yep. Save this, and then in a new line, paste that. And then finally at the bottom, we say connection error is equal to rmq open connection. And the first one is the tag. I'm just gonna say my service. This is just like names. There's no real strict bounding to this. And then the network is going to be the TCP network, and then finally localhost colon 6379, and then 6379, and then finally the last one is going to be the second last one is going to be the DB number. So Redis has DB numbers. I'm just going to put that as one. It doesn't matter. And the last one is an error channel, because you can asynchronously process Redis errors. In this case, I'm not really going to go through all that. I'm just going to go through like a very basic case. And then finally, I'm going to say if error does not equal nil, log.fatal error. And then, yeah, save that. Log log.fatal. Okay, that should get the log stuff in. And then finally, let's just open our task, our queue over here. Just call this a task queue. And we'll say task queue and error is equal to connection dot open queue, and we'll call this task over here, or task plural. And the same thing, just want to handle the errors over here. Log.fatal error. Cool. So now this opens up our queue over here. So now we can start doing stuff within our producer and a consumer. First thing we want to do is we want to run something in a different Go routine. So the way we're going to do that is over here. We're just going to say go func, and then we want to self-run this, and then inside this go func we kind of want to produce task. So we're going to create a ticker because we want to produce these tasks on like a timely basis. So this is time.new ticker, and then we got to put in a duration. Let's say we want to do this every 1 second, so time.second over here. And then we want to run this on a for loop, and then we want to select a select case over here. So case where we receive something from the ticker, ticker.c. And then in here we can do stuff to produce things. So now just for us to keep track of different tasks, we don't want them all to have the same name. We'll sort of have to increment them by a digit. So we're going to call this a payload over here. Payload is equal to fmt.sprintf. We'll call this task, and we'll put the number over here by saying I. So that's going to be our payload, and now we push the payload onto the queue. So we'll do task queue dot publish, and then we just pass in our payload over here. One thing is that this does also cause an error, or return an error. So let's just handle that as well. Error does not equal to nil, then log.fatal is the error. Cool. So the reason why we ran this in a Go routine is because this Redis queuing service allows you to also have an HTTP server where you can sort of see statistics related to your queue. Is it processing tasks? What services are attached to it, and all that stuff. So we'll create that handler soon. We just want to create the consumer now. So over here, we're going to do the same thing. We're going to use the task queue, and we're going to add a consumer over here. So there's two different ways. You can add a consumer, or you can say add consumer func. And this one is sort of easier because you can just like attach a function to it. The other one, you need to pass in a struct which complies with an interface. So that's like a bit longer for sure. So let's just name this task consumer over here, and then we just want to have a function over here. So this function is going to run asynchronously in the background, sort of taking and processing a task. So we're going to do log printf over here, and then how we want to do this. We're going to also pass in a consumer name so we can sort of distinguish between consumers. So for the first, I'm just going to put this in square brackets, %f, and then I'm going to say performing task %s to string interpolate. And so now if you want to take more arguments from the CLI, read the documentation, because I'm not going to go too deep into this, but if you do context.args.first, you can get the first argument off the chain. And then finally, we can do d.payload over here, which is going to give us the payload off the queue. And then finally, we need to acknowledge that we successfully processed this. So we're going to do that too, and it's going to return an error as well. So d.acknowledge, and if error does not equal to nil, then we log.fatal error. Cool. So essentially, this is like all we need to run this, honestly. There's nothing more that you need to do. That's pretty much it. One thing is that we need this runs asynchronously. So this will run, and then the code will continue running, and it will sort of like boggle out over here. So at the very end, just for ease, I'm just going to say time.sleep time.sleep just so this program stays alive, and I'll do it for an hour over here. Cool. So now that should pretty much get us set up with all of that. We want to create our handler function just so we can appropriately run stuff. So the way we're going to do that is over here in our producer, we're also going to run the server. So we're just going to say http.handle, and over here we're going to create an endpoint call overview, and inside here we're going to create an http.handlerfunc. Where is it? Handlerfunc over here, and this takes in a function. Cool. So now in here we can do all our stuff. First we're going to, let's see. Okay, so in here we can get our stats. So we can say connection dot get collect stats over here. So that should give us our stats. But it's also going to take the list of queues. So we're going to say connection dot get open queues over here. So that should give us our queues and our error. And then we take that queue and we pass it in here, and that should give us our stats. Also return an error over here, and then finally at the very end we want to return that to the user. So we say fmt.fsprintf fsprint over here, and then it's going to take in our writer, and then it's going to say stats.getHTML, and we're just going to pass empty strings over here. Layout and refresh are parameters you can pass in. Definitely look into that. But in this case, we don't need it because it's super basic. So if does not equal to nil, then we just do log.fatal error, same thing. And then over here, same thing. If error does not equal to nil, then log.fatal error as well. Cool. So that seems like it should have done what we needed to. We ran our Redis instance in the background, so let's see if that works over here. Okay, seems like it's set up over here. So if you open this and edit, you see it has very basic configurations for port and localhost. It doesn't have username and password because we turned that off. And since I'm opening this up, means that it works. So now let's do one thing. Let's run this, see if we have any errors first of all. So go run main.go, and we want to run our producer over here. Mr. Producer, got all the best shows. Mr. Producer. Oh, okay, so it's producing that probably right now in the background, but I think something is, let's see, because then this would be populating. Okay, yeah, it is populating over here, and it's populating incorrectly. I forgot to increment the I, so that's my fault. Let's do one thing. Let's cancel this. Open this up over here, and let me just delete this for now. Okay, so at the very end of this for loop, I want to pretty much I++ over here, and I just want to just fmt.println the payload as well. Cool, so that's done. So after this runs, then it runs the HTTP stuff. One thing I forgot to do is to actually run the HTTP handler. So at the very end over here in overview, at the very bottom, you gotta do http.listen serve, and this is going to be on port 333, and then I'm just going to pass it nil over here, and then this also is going to return error So you go to nil, log dot fatal error. Just say if error. Cool, so that should be it now. Let's try to run this one more time, and we should see now that it's trying to run our HTTP server as well. So let me allow that, and over here you can see it producing the task, so that's good. Let's do one more check over here. So if we go over here and do localhost 3333, oh yeah, /overview. You see now it's creating our task over here and putting it into the Redis queue. So let me zoom in a little bit. Um, yeah, and it's putting it in over here, which is pretty cool. It's doing what we need to. So now let's go over here, open our next window, and let's create our consumer. So if we do go run main.go, and then our consumer name, let's name it t.code over here. Oh wait, I didn't say consumer. So now this will run our consumer over here. Oh, one thing I forgot to do is to start consuming. We do need to specify that. So over here, if we say task queue dot start consuming, you want to put in how many things you want to consume at once. So in this case, I'm just going to say 10. It's totally up to you how much you want to do and how often do you want to pull. So I'm going to say every second you essentially want to pull. So it's going to try to pull in 10 every second. Let me clear this and let me run that same command once more. Cool. So now you see that it's logging what we are doing over here. So it's putting in t.code over here and it's performing this singular task. So right now it's pretty much at publishing 148 and it's catching up, and essentially now it's pretty much done. So if we refresh this, it says 0 are ready and there's one consumer attached to it. These are all the services that get spun up and get named. So this name over here, we put it at the very top over here. So that's the service that's getting connected to it. So let's say we want to add one more consumer, right? We do go run main.go consumer, and we want to name this Steve over here. So now this should also attempt to consume and try to share task with this. So if you notice one thing interesting, it's they're not overlapping, like they're not picking the same task, which is exactly what you want in some situations. Like you want just to process things off the queue, and you don't want others to sort of pick it up and also process it again. So that's great. So you notice how both of these are kicking off. If you've noticed, we have this rejected queue over here for rejected task. And let me show you how those would probably get filled over here. So instead of acknowledging it, we would have to, what's the other one? I forgot. Reject. Yeah, so we essentially reject it and it'll go into our rejecting stack. So let's say we go over here and we run another t.code. In this case, we only need one, so I'm going to delete this. It says performing task, but we're actually rejecting it. And the way we can tell is if we go over here, we can see our rejected queue is now getting more and more over here. So let's do now one thing. We want to move it from the rejected to back into ready. So let's say you want to retry every now and then. What we can do is let's create another endpoint over here, and we'll call this refresh over here. So now in refresh over here, we don't need all these stats and connection stuff. What we're going to do is take the task queue and we're going to return rejected over here. Now what it's going to take, it's going to take in two arguments. One is the number of rejected tasks you want to move from the rejected task to the ready task again. So what you can do is if you want to do it all, you can just say math dot max int over here, which will just toss them all in. and essentially it will return you two things. First, it'll return you the number and the error over here as usual. So you're just going to say if error it does not equal to nil, then log dot fatal error over here. And then finally, you just want to return this to the user. So I'm just going to say fmt.sprintf over here. We returned percent %d task from the rejected stack. Cool. So now let me put that in. Cool. So now let me restart this over here because we don't have that endpoint ready. Um, cool. So now that started spinning it up and started up producing more tasks. So now if we take this and go over here and say refresh, so let me notice right now there's 148 rejected. So if we hit this, now it says we return 161 tasks from the rejected stack. And if we go over here, we see it got pushed back to the ready stack, and we're still technically in a forever rejecting loop. So if we go back here, we see like it keep rejecting and rejecting and rejecting. So now every time I hit this again, it will move stuff from the rejected stack back into the ready stack, and you can sort of retry this mechanism. So now let me just really quick change this to acknowledge over here, save that, and let me rerun t.code just to clear this up. And we should see the magic unfold over here where it's processing it. And if we go to the refresh, we should see 120 that moves back from here back into the ready. And then now t.code consumer is taking it off the queue and just processing it once as possible, fast as possible. And that's pretty much the end of this video. Just wanted to show you basically how you could use RMQ for your Golang services. If you need something really lightweight and not that serious, because eventually for more like production heavy level stuff, you might want to use Kafka or RabbitMQ or something along those lines, because one of the main differences between, I guess, Kafka and then this would be that we don't have consumer groups in this. And consumer groups is a different topic, but different services can sort of consume the same thing twice if they have different names and stuff like that. But in that case, I hope you enjoyed this video as much as I did. If you did, please show your support down in the comment section. Drop a subscribe, a like, and yeah, I will see you in the next video. Peace.